So ROC is stable system. So it's a transform of x of n. Now by the definition of is a transform, we got the value, and this is the value we got it. Z is equal to 1. So on taking absolute value on both side, we got it. So this is the value we get it. So therefore, we have to conclude z is equal to 1 will be the point in the ROC of the stable system. Hence, for the stable discrete time system, the ROC of impulse response should be included into unit circle. So general condition for stability in Z plan. Okay. So general condition for stability in Z plan. So on combining the condition for the location of poles and ROC, we can say that for the stable LTI linear time invariance discrete time system. So that the unit circle and a unit circle should be included in the ROC of the impulse response of the system. Frequency response. The frequency response is LTI discrete time system is represented by the constant coefficient different equation. That is the equation y of n is equal to minus summation of m is equal to 1 to n. So the equation shown in the slide, the solution the above different equation is total reverse response y of n of LTI discrete time system. It consists of two parts in signals and systems. The two parts of the solution y of n are called zero input response and zero state response. So y of n is equal to y zi power of n and of n. Zero input impedance or free response or natural response using the transform. So the zero input response is mainly due to initial output in the system. The zero input response is obtained from the system. The equation when input x of n is equal to 0 and the substituting x of n is equal to 0 and y of n is equal to y z I. So this is the equation we got when we got 1. So we got the y equation, and on taking z transform of the above equation with the non-zero initial condition, the zero input response the discrete time system is inverse z transform, and zero state response or forced response. So the zero state response is obtained from the different equation one in the system for the specific input signal x of n, and substituting the value of the equation we got it. This is the equation we got the values, and finally the taking z transform the above equations with the zero initial conditions, uh, the zero state response of the discrete time signal is given in the inverse z transform. So what about total response? So previously zero response, frequency response we already seen. The total response y of n is equal to the response of the system due to input signal and the initial output. So that is called as total response. Then thank you.